సాల్వ్ చేశారా?
చేశాను సార్.
డౌట్స్ ఉన్నాయా లేవు? లేవు, ఉన్నాయి. ఓకే. So anyway, so before going to the next topics, again I will revise the previous topic. What is the previous topic? So the previous topic is line integral, line integrals. So before going to the line integral, just I think we have seen the finding the length of the arc. So length of the arc of the curve. So that is the AC is equal limit n tends to infinity summation I is equal to 1 to n under root of delta xi whole square plus delta yi whole square. And after separating delta xi and delta yi, we have the two parts. Okay, after separating the delta xi, the result here we will write integral a to b under root of 1 plus f dash of x whole square into dx. After separating the delta y, integral c to d under root of g dash of y plus 1 into dy. That means finding the length of the arc, we have the two options. With respect to x or with respect to y, we can solve. That is the first one. That is in the Cartesian form. So these are the curves given in the Cartesian form. So we have the two options. We can find the length of the arc is integral a to b under root of 1 plus dy by dx whole square in dx, or x is the length of the arc is integral c to d under root of dx by dy whole square plus 1 into dy. So two parts. It is in the Cartesian form. Next one, same, we have parametric form also. So that is, if x is function of t and y is function of t and the t limits from the t1 to t2, the length of the arc is integral t is equal t1 to t2 under root of dx by dt whole square plus dy by dt whole square into dt. So this is the finding the length of the arc. And one more, we have the polar form of the arc length, that is the s is equal integral theta 1 to theta 2 under root of r square plus dr by d theta whole square into d theta, r theta is equal to function of r and r limits are r1 to r2 and s is equal to integral r1 to r2 under root of 1 plus r square d theta by dr whole square into dr. So finally we have the three varieties: Cartesian form, parametric form and polar form. Okay, I think we have seen in one problem also. So the length of the arc, so the length of the arc, it is the sector. So from the diagram, the length of the arc is pi by 2 because the perimeter of the circle is 2 pi. So 0 to in the first quadrant, the length of the arc is pi by 2. So this is from the first method, that means with respect to x. With respect to x means now the circle equation x square plus y square is equal to 1. After separating the y, then y is equal to under root of 1 minus x square, and the formula for finding the arc length is integral a to b under root of 1 plus dy by dx dx, and here the x limits are 0 to 1 only. So finally we will get the pi by 2 is the result. So this is the first one. Similarly second one, we can easily find with respect to y also. That means first of all separate the x. After separating the x, we will get here x is equal to under root of 1 minus y square, and dy by dx by dy is equal minus y by under root of 1 minus y square, and the formula for finding the arc length is integral c to d under root of 1 plus dx by dy whole square into dy. So now, so here also we will get the result pi by 2. Okay, this is the second method. Next one, parametric form. Same problem we will solve in the parametric form, but we will take the x is equal to cos t and y is equal to sin t, and the t values are 0 to pi by 2, and the formula is integral t1 to t2 under root of dx by dt whole square plus dy by dt whole square into dt, and after simplification we will get the definite, we will get the pi by 2. So this is the arc length by using the parametric form. Okay, now come to the, so it is the parametric form of the arc, but it is in the two variables. Now we will extend to the three variables. That means the, if the length of the arc is in the two variables is integral t1 to t2 under root of dx by dt whole square plus dy by dt whole square dt, if it is two variables. Now we will extend to the further three variables. Just add, introduce just z is equal function of t only. Then the length of the arc is integral t1 to t2 under root of x dash whole square plus y dash whole square plus z dash whole square into dt. So this is the parametric form of the curve, and this is the formula for finding the length of the arc for three variables. Similarly, we can extend to the four variables, five variables, n variables, like that we can extend. Now the next one is here. So actually we have finding the line integrals. Line integrals. So line integrals, I think we have seen in the previous class, line integral with respect to arc length, line integral of the vector space, line integral of the field, scalar field. Now here C be a simple curve, and the parametric form of the curve is x is equal function of t and y is equal function of t and z is equal function of t, and t is in between a to b, and I am assuming the here the position vector is r. Now r is equal xi plus yi plus zk, and x, y, z are function of t. That means we are taking here these functions are in the t. That means parametric form of the curve. And the first one is line integral with respect to the arc length. So line integral with respect to the arc length. So here the function f of x, so f is function of x, y, z, continuous function on the curve. The curve is here x is equal to function of t, y is equal to function of t, z is equal to function of t. The line integral of the curve with respect to the arc length is integral f of x comma y comma z ds. Here ds means it is the arc length. The arc length here under root of x dash whole square plus y dash whole square plus z dash whole square into dt. Now this is the formula for finding the line integral with respect to the arc length. I think we have seen in the previous class few problems. Okay, this is the first problem in the previous class. They evaluate the line integral x y square into ds, and the curve is given that x is equal to 3 cos t and y is equal to 3 sin t, and t in between 0 to pi by 2. Okay, so substitute x is equal to 3 cos t and y is equal to 3 sin t, substitute, and ds means under root of x dash whole square plus y dash whole square plus z dash whole square, that is we will get, after simplification we will get the 27. After substituting all we will get the line integral of this one, we will get the 27. And come to the next second problem. Okay, here in the second problem, so evaluate the line integral x square plus x z ds, where the c is the curve defined x is equal to 4y and z is equal to 3. Okay, observe in the previous they have given clearly x and y, x is equal to function of t, y is equal to function of t, but in the second problem they have not given parametric form. They have given some curves x is equal to 4y and z is equal to 3, z is equal to 3. So from this one we will find the parametric form. So parametric form, here we have the two options. By taking the x is equal to t we can form the parametric form, or by taking the y is equal to t also. If by taking the x is equal to t, then the t limits are 0 to 2 to 4, and if y is equal to t, the t limits are 1 by 2 to 1. And here the ds, if it is suppose x is equal to t, the ds value is under root of 17 by 4 into dt. If suppose y is equal to t, ds is under root of 17t. Okay. So here the ds and ds, here we have the different result, but finally we will get the same answer. Okay. Now if I am taking, suppose x is equal to y is equal to 1 by 4 and z is equal to 1 by 4t and z is equal to 3 and ds is equal to under root of 17 by 4 into dt. So after simplification here we will get the 55 under root of 17 by 4. Or if I can take, suppose y is equal to t and x is equal to 4t, z is equal to 3 and ds is equal to under root of 17t, then same we will get the same answer. That means the, if it is, sometimes they will not give the parametric form, so we can convert into the parametric form. That is not unique. That is the final conclusion. Okay. And I think I have given two problems in the previous class, homework problems. So same, the first one is x is equal to 2 cos t and y is equal to 2 sin t. Directly they have given the parametric form, but in the second problem they have not given the parametric form. Okay. So here you can take, here you can start with the x is equal to t or y is equal to z is equal to, that is your choice. Okay. If suppose x is equal to t, then our limits are 2 to 4. If y is equal to t, 4 to 8 and z is equal to t, will get the 4 to 8. So that is your choice. Okay. Next one, that is the first one. Next one, line integral of the vector field. Same as the previous one. The previous one is the line integral with respect to the arc length. Now here line integral of the vector field. That means here the C is a simple curve and the curve is the parametric form. That means x and y, z are function of t and t values are in between a to b. And the f is a vector field. That means f1i plus f2j plus f3k and f1, f2, f3 are continuous function and the given curve C. The line integral of the vector field over C is integral, the line integral of f dot dr. So f is the given vector space and dr is the related to the position vector and dr. So dr is dxi plus dyj plus dzk. But here the, if you can write suppose parametric form, now the dr is equal to dx by dti plus dy by dtj plus dz by dtk into dt. Substitute. Now here we will get the three different integrations. First integration related to f1, second integration related to f2 and third integration related to f3. I think in the previous class we have seen two problems in this line integral of the vector field. The first one is f is equal, it is the vector field and from the 0 0 0 to 1 1 1 along the path x is equal to t and y is equal to t square and z is equal to t cube. It is given that parametric form and from this one we identified the t limits are 0 to 1 only. Now already here just we want to find the dot product of these two, that means FDR. After taking the FDR, here the f1 into dx plus f2 into dy plus f3 into dz. But here the x, y, z are function of t, just dx is equal to t and dy is equal to 2t d and dz is equal to 3t square dt and x, y, z already they have given. Substitute. After substituting it will total in terms of only t. Just do the normal integration. We will get the final answer is 5 only. So we will get the final answer is exactly 5. So this is the finding the evaluate the evaluation of the line integral of the vector field. Same. So I think second problem, same type of problem. So it is given that it is the vector field x square I minus 2yj plus z square k and it is given that over the straight line path from minus 1 2 3 to 2 3 5. Okay, observe in the previous form they have given directly parametric form. It is here parametric form is not given. From these 2 points we have to find the parametric form of the straight line. Okay, so here we have the two options. The first option is you can take x minus x1 by x2 minus x1, y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1 is equal to, substitute the values. Then after substituting we will get the x is equal to 3t minus 1 and y is equal to t plus 2 and z is equal to 2 2, so 2t plus 3 and the position vector is finally we will get the position, this is the position vector. Okay, it is the first approach. Second approach, so here suppose A and B are the two vectors. Now this one I can rewrite, so we can adjust the vectors 0 to 1 also by substituting A and B, that means A of 1 minus t plus B t, or A plus B minus A t. Substitute here, the A is the first point, B is the second point, that means after converting the vectors. Now we will get the same result, R is equal 3t minus 1i plus 2t, so t plus 2j plus 2t plus 3k, and the t values are in between 0 to 1. This is our position vector. Okay, now we have the position vector and f, just we can easily find the line integral. That means the dot product of this position vector and vector field. Okay, so just substitute. Now the total result in terms of t, just to evaluate, we will get the total 92 by 3. So this is the line integral of the vector field. I think I have given two homework problems. So the first one, direct problem, that is x is equal to t square given and y is equal to 2t given, z is equal to t directly, that is there is no objection directly, and t value is 0 to 1 also given. But the second problem is I think directly x is equal to cos t and y is equal to sin t and z is equal to t, and t value is in between 0 to pi by 2. Okay, that means these two problems are very simple because directly they have given the parametric form. And come to the third one. Third one is the line integral. Okay, sir. Oh, sir. Third one. So line integral of the it is not given the parametric form. It is given that find the work done in moving the particle once around a circle in xy plane with center at origin and the radius is 3. So it not given, just you have to convert into the parametric form. That means the circle equation is x square plus y square is equal to 9, and xy plane means z value 0, and after converting the parametric form, x is equal to 3 cos t and y is equal to 3 sin t and z value 0, and the total circle means you have to take the t is in between 0 to 2 pi. Okay, finally here the result of this problem is 18 pi. Okay, this one is about the line integral of, hello
sir, first problem result cheppara.
ఫస్ట్ ప్రాబ్లం మీకు ఏమొచ్చిందండి?
52 by 15 plus e square by
52 by ఒక్క నిమిషం 52 by
15
15 ఓకే
plus e square by 2.
ఓకే, కరెక్టేనా అండి? ఓకే, సో దిస్ ఈస్ ద కరెక్ట్ ఆన్సర్. సో 52 by 15 plus e square by 2. ఓకే, ఇంకా సెకండ్ ప్రాబ్లం ఓకేనా?
Okay, sir.
Third, okay, okay. So this one is about the line integral of the vector field. Next one, line integral of the scalar field. So it is not different from the line integral of the vector field. So this small difference, they have in the line integral of the vector, they have given the vector field, and here they will give the scalar, and directly in the previous line integral of the vector field, so you have to take the dot product of the f and dr, but the line integral of the scalar field directly f1 dx plus f2 dy plus f3 dz only. That means, so technically that means mathematically it is the not there is no difference between the line integral of the vector field and line integral of the scalar field, but physically it is some different. Okay, mathematically there is no difference. Okay, that is the observation. So that's why here I have given only one problem in the line integral of the scalar field. Okay, directly they have given the three function f and f, g, h. You have to find the line integral of f dx plus g dy plus h dz only. I think we have seen only one problem in the previous class. Okay, one problem. Directly it has given that integral 2xy plus 2xy 2x plus y dx plus y square dy plus x plus z into dz. Okay, it is the line integral of the scalar field. But same problem they will give in line integral of the vector field also. If vector is like this, 2x plus y I plus y square j plus x plus z into k, and the curve is same. And here according to the previous one, it is given the curve, so the curve just convert in the parametric form. So in these two problems, so in the first problem we have to assume x is equal to, after assuming x is equal to, y is equal to 1 by 2 t square and z is equal to, and the t values are in between 0 to 2. In the second problem, y square is equal to x, means in this one you have to assume y is equal to t, then y is equal to t, then x is equal to 1 by 2 t square and z also 1 by 2 t square, and x t is in between 0 to 4 only, so 0 to 2 only. And after substituting for the first problem, you will get the 12 answer. Second problem you will get the result. Second problem mute lo pettandi evaru సిఆర్ శైలజ. ఓకే, సో మీరు మ్యాక్సిమం మ్యూట్లో పెట్టండి, ఒకవేళ మాట్లాడాలనుకుంటే అన్మ్యూట్ చేసి మాట్లాడు. ఓకే, వింటున్నారా సియాస్? ఓకే, ఎవరెవరన్నా మ్యూట్లో పెట్టకపోతే వాళ్ళ కాల్ని రిమూవ్ చేసేయండి. వింటున్నారా సియాస్? ఉన్నారా నలుగురు సిఆర్లు? C1 C2 C3 C4 సిఆర్స్. సో ఇమీడియట్గా వాళ్ళ గూగుల్ మీట్ కాల్ని కట్ చేసేయండి. ఓకే, రిమూవ్ చేసేయండి. ఓకే, ఎక్కడికి వచ్చాం సిఆర్? ఎక్కడికి వచ్చాం సిఆర్? homework problem work వచ్చాం. ఓకే, సో the result is homework is result ఇచ్చానా? ఓకే, now same problem they will give like this also. F is equal x plus y I minus x square j plus y plus z k, and the curve is x square 4y and z is equal to x. X is in between 0 to 2. Second one is y square is equal to 4x and z is equal to x, and x is in between 0 to 4. They will give the question like this also. Then find line integral of f dot dr. Okay, same meaning. So this is related to line integral of vector field, and this is line integral of scalar field. Okay, we get the same answer. Okay, so this is the about the previous class. So any doubts from the previous class?
సార్ లాస్ట్ ప్రాబ్లంలో సెకండ్ సబ్ క్వశ్చన్కి కూడా 10/3 వస్తుందా సార్ ఆన్సర్?
మీకేమొచ్చిందండి సిఆర్ గారు?
368/15 వచ్చింది సార్.
368/15 కరెక్టేనా ఆన్సర్? సో యాక్చువల్లీ ఈ ప్రాబ్లమ్ సాల్వ్ చేయలేదు, మీకు ఇన్స్టాంట్గా ఇచ్చేస్తాను. ఓకే, క్లాస్లో నిన్న అది ఫస్ట్ ప్రాబ్లం చూసి సెకండ్ ప్రాబ్లం ఇచ్చేస్తాను. ఓకే, సో నా దగ్గర రిజల్ట్ ఏది మీకు ఏమొచ్చిందండి ఒకసారి చెప్పండి. షూరా?
షూర్ సార్.
ఓకే, థ్యాంక్ యూ అండ్ వెరీ గుడ్. సో 368/15. ఇంతకుముందు కూడా ప్రీవియస్ క్వశ్చన్ కూడా 15 వచ్చినట్టుంది, బై 15. ఓకే, కరెక్టేనా మీరు సాల్వ్ చేసింది?
కరెక్టే సార్.
సో నెక్స్ట్ క్వశ్చన్ కూడా సాల్వ్ చేస్తే బై 15 వస్తుందా? ఏమో చూద్దాం. ఓకే, సో థ్యాంక్ యూ.